This is day 12 of Advent of Code, and this challenge is called Hot Springs. You finally reach the hot springs. You can see steam rising from the secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing, and suddenly notice the massive metal helixes towering overhead. This way. It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged. The puzzle input are also damaged. You'll need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it is operational or damaged. This is the part of the condition records that is itself damaged. For some springs, it is simply unknown whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list always accounts for every damaged spring, and each number is the entire size of its contiguous group. That is, groups are always separated by at least one operational spring. These 4 in a row would always be 4, never 2, 2. So condition records with no unknown spring conditions might look like this. So you got 1, 1, 3. 1, 1, 3, 1, 3, 1, 6, 4, 1, 1, and so on. However, the condition records are partially damaged. Some of the springs conditions are actually unknown, with a question mark. For example, there are 3 unknowns here. There's 2, 2, 1. Equipped with this information, it is your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. In the first line, there is exactly one way separate groups of 1, 1, and 3 broken springs. One way to separate groups of 1, 1, and 3 broken springs in that order can appear in that row. The first 3 unknown springs must be broken, then operational, then broken again. Broken, operational, broken, making the whole row this. The second line is more interesting. Question mark, then 2 here, then 1 here. Could be a total of 4 different arrangements. The last question mark must always be broken to satisfy the final contiguous group of 3 broken springs, and each question mark must hide exactly one of the 2 broken springs. Neither the 2 question marks could be both springs, or they would form a single contiguous group of 2. If that were true, the numbers afterwards would be 2, 3 instead of 1, 1. So since each 2 grouping of question marks can be broken normal or normal broken, there are 4 possible arrangements of springs. The last line is actually consistent with 10 different arrangements, because the first number is 3. The first and second question mark must be dot. If either were hash, the first number would have to be 4 higher. However, the remaining run of number springs conditions have different ways they could hold groups of 2 and 1 broken spring. In this example, the number of possible arrangements for each row is 1, because you've got 1 blank 1, like that. And this one could be 10. So it can't be that, it has to be 1, 2, 3. But then it could be 2, 1, 1, 1, 1, 2, 1, 1, and so on. So adding all the possible arrangements counts together produce a total of 21 arrangements. For each row, count all of the different arrangements of operational and broken springs that meet the given criteria. What is the sum of those counts? So we'll start off with copying this into our input here, though we need to remove the extra spacing and text that's not needed. So like that. Let's double check what our input looks like to begin with. Okay, it's quite a lot. So we will first start off going line by line. We'll grab the pattern, and then we'll grab the numbers, So for line in input, we have total equals 0, then we will return 0. We will do, that should be return total, but we will do pattern numbers equals line dot split. Now let's print pattern numbers to make sure that works. Those work. But then what we'll do after that is numbers equals for num in numbers dot split on the comma int num. Now let's see if that, okay, so it prints those numbers out as a list. Cool. Okay, and now comes the more difficult part. I'm not really sure what the best approach for this is. So there's a brute force approach where you go, okay, this is going to be 1, so that means this is a dot, and then this is 1, and there's nothing left, so that is one possible combination. You go to the next one, see if that works, that can go in there, but this then becomes a dot, but then there's nothing left, so you can't do that anymore. And then for this one, you can do this, turn this to a dot, do this, turn that to a dot, then this one works, then you could switch it around. But what's the best approach to do that in code? That is the real question here. So we do need to iterate over the pattern. Okay, so this is going to end up being a recursively round function. So let's create a function. What should this be called? Kind of just guessing what I need to do for this. We'll just call it iterate. And what we need for iterate, we need the pattern index, so we know where we are in it. We need number index, so we know which number up to, and we'll pass in total. Okay, so we have that, and then for down here, it would end up being total plus equals iterate, and you start on 0, 0, total. Oh no, you start on 0. So you'd run it like that. So one problem I do see with this, actually also pass in pattern and numbers, so it has access to that. So what we need to do to actually go over this, so I guess we could start, just so we have literally anything down. So we're going to be incrementing both p-index and n-index. So I guess to begin with, we're going to just, we know we're going to end up returning the total, so we'll just do that. And how are we going to be increasing total? So this is going to be a recursively round function, because we need to iterate over the pattern, and we need to find all the ways that the numbers can fit into it in each possible combination. So I guess we can start off with when we're at the very end of it. If p index equals length of pattern, this will be the last time to check whether the numbers can fit inside, so return 1 if n index is equal to length of numbers, else 0. So if we're not at the end of the pattern, we then actually do the proper check, which I'm still trying to figure out what the best way for this is. So I guess one thing that we need to look out for, the question marks isn't a guarantee that the number is going to be on it. Like in this case, you could get rid of both of these question marks, and that's 1, 1, 3 in there. So at some point we have the pattern index, and we need to look to see if the number fits in it. Let's do pn index equals p index plus numbers n index. So that's going to be used at some point to figure out whether the number fits in the pattern. Okay, so that's a good starting point. What we can do next, okay, so yeah, I've got an idea now. So pattern p index, if pattern index in hash or question mark, so a number could start here, and we need to look ahead. So the way that a number could fit in there is if dot isn't there, so and dot not in pattern p index up to pn index. So for now checking, so we've got a good starting point. We're going forward the length of our current number, and we're seeing, okay, can it actually fit in there? Or in other words, is there no dot there? So if that works, we then iterate, and this will start from pn index plus 1, because we've now gone to the end, and I want the one after. Pn index plus 1, n index plus 1, total pattern numbers. So running that, and that is total plus equals. I need to remember that every time we run iterate, it's total plus equals pattern. And we also need to think if pn index is greater equal to length of pattern, return total. Is there anything else I'm missing for this? So we're currently not checking to see if the current number is dot or question mark continue. Because it could be that if it's question mark, it's meant to be a dot, so then we check another one, or if it is a dot, we need to continue. So what we'll do, if pattern p index in dot question mark, and it's this without the n plus 1, and change that to p. So first iteration 0 0 0 0. It's not this, so we carry on. If it's a question mark, so this implementation, I think it goes like to the end first, and then comes up. Oh, it keeps going until it's a hash. When it's at that point, it kind of forces you to perform the proper check to see if the number can fit in. But then what happens, like if it's a hash, it will then return back up to here, so the previous one, and there might be a question mark that it did it. Then it'll go down to here to question mark. You know, I haven't ran anything in ages. I just want to see what it does. Yep. Okay, that's fine. Let's add iterate pattern number numbers. Let's run that. Okay, list out of range. So that's pn numbers. Okay. I guess in this part we can do if. So we already got the p index check. Now we just need to do if n index equals length of length of numbers. We then just return total and then runs. Okay, that number. Where did that number come from? Oh right, the issue is right here. I'm doing plus equals, but then at the same time I'm passing total into it, so it should just be equals on this. Shouldn't be plus equals. And same thing there. Yeah. Okay. Yeah, I was passing the value on. Plus equals is only if I'm separately in the next call creating a new instance of total, but we aren't, so no need to do what we did just then. And now it's turning 1. Okay, I think I need to change how that works, because it's not right. So maybe I don't actually need to pass total into it. So we'll change it back to what we had before. So we've got the plus equals back, but total equals 0. And we remove total from here, and here, and here. So now what does that do? 26, or again, we returned 21. So we'll do num equals this, print num plus equals num, just so we can visualize what's happening. So first one returned 0, 0, okay, 4, 1, 1, 4, 16. Something that might be the problem. It's this here. So just trying to look at what the cause may be. So pn index, if it's greater than or equal to length pattern. Actually, I don't think that is. Well, we'll try remove the equals from here. I always forget how this works. But we'll just see what it gives. I'm not sure how this messed it up. Sure. Okay, so for the sake of not having to worry about these, I'm just gonna chuck in a try except, because it's annoying having to worry about all this. So try except, and that is. So we don't. I'm very tempted just to accept exception, but no doubt I'll make another error. So this is index error, and let's pass. Just because if it's out of index, then we just return total. Does that do anything? No, it doesn't. Okay, well, I gotta keep thinking of other ways that this could be broken. Okay, so I spent ages trying to figure out what the problem was, and basically it took me forever to figure out things which weren't working. So the first one was right here. So we were doing if it equals hash or question mark and then dot not in this, we were like, okay, the number will fit right into here. But we didn't take into consideration if the following number was a hash, which means it had to fit that whole number. So let's say it was hash question mark hash. We were doing, and we had the number 3. So we're going hash question mark question mark. Okay, that is all good. But really, there was a hash there, so it had to be 4. So that's why we need to do and hash is not the following number. And then something which I played around with, and I have no idea why it made it work, was adding a dot to the end of the pattern. Like if we remove this, we get completely different numbers. Add it back, and now it works. And I'm not sure why, because if you look through here, we're to get to the point where it's if pattern p this like on this input, we get to this part. Oh, I just figured it out while saying that. This is the part with okay. What's happening if I remove this? It's doing this part on the very end, but then it tries to look after that. That's why. Okay. Well, at least I now actually know why my solution works. So we add a number at the end just to say as a placeholder in case we get to this point. Okay. But anyway, we run that. We now get 21. So time to get the actual input. So we'll copy that and put it into here. And we'll now run it. 6,981. And that is the answer for part 1. So now on to part 2. As you look at the field of springs, you feel like there are way more springs in the condition records list. When you examine the records, you discover that they were actually folded up this whole time. To unfold the records, on each row, replace the list of spring conditions with 5 copies of itself, separated by question mark, and replace the list of contiguous groups of damaged springs with 5 copies of itself, separated by commas. So this row becomes dot hash separated by question marks, and so the first line of the above would become that. Okay, I think I understand what's happening there. So if we go back to our original and copy this to part 2, let's get rid of this print statement. So pattern. So this would be pattern plus question mark. Actually, let's just do that here first. In print statement print. So print pattern and numbers. Actually, let's just run that once and exit. Okay, got those that now. Let's do plus question mark times 5. Yep, that looks correct. And it even has the question mark at the end, which would handle this case. Yep. And now we need to do numbers. Is that just times 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that. Okay, cool. So hopefully that's all that needs to be done. So we're just copying those into the input part. So now let's run that. That looks like the correct answer actually. Yeah. Okay, cool. So I guess we will switch to the actual input, and now let's run it. Okay, so from looking at the input, considering it's times by 5 and it's still running, that's not going to work running it just like that. So looking at the input, it's going to be running it a bunch of times, but in the same exact way. Or in other words, it's going to be what gets passed into the function, like here, it's going to be repeated multiple times. So what we really should be doing is caching the results of that function call. So that function call with the exact same parameters. So what we can do from functools, import cache. And then on this function, we can just put the cache decorator on top of it. And what that does is when you run the function, it's going to save the results of it based on the inputted parameters. So if you try to run it again, it's going to return the exact same results, which sounds like it should be the perfect solution for this, because we're going to be getting instances where, okay, 1 is here, and then I'll try 1 here, here, and all the possible combinations. Then we'll go to the next one. It's going to be trying to do the same substring and inputs again, so there's no point in calculating all that. But the thing is, it's going to be trying to calculate that for every single one, and it's going to be doing it a ton of times. So it might actually just be a good idea to cache it. And okay, what do we do? Unhashable type list. Where was that? So we need to turn that to a tuple. And now let's try that again. Unhashable type list. Alright, it needs to be done for both of them. Because now part 1 is getting the cache one as well. Oh, that was way quicker than I thought it would be, but I guess that's the power of caching results. So we've got that massive number, and it's absolutely no surprise that it wasn't going to work doing the brute force way. So we'll now submit that. Awesome. And that is part 2. So that is day 12 of Advent of Code 2023. If you like this video, make sure to like and subscribe so you can watch me complete the rest of these challenges.